Okay, so we're going to look at radical expressions and rational exponents. So we're going to be doing those problems with fractional exponents, though. Okay? And we're going to learn how to take these problems and if we have a fractional exponent, write it as a radical like number 4 here. Now you're probably familiar with finding square and square roots of a number. Excuse me. All right, these two operations are inverses of each other. All right, so similarly, there are roots that correspond to larger powers. So the nth root of a real number, a, can be written as this radical expression. The nth root of a is what that says. If there was nothing there where the n is, you would say the square root of a. Right? If there was a 3, we'd say the cube root. Any other ones, we'd say the 4th root or 5th root or 6th root or so on. Okay? Well, what that root refers to, that value there refers to, okay, a to what power equals that number? Okay? Right. So we're saying that's like doing, okay, comparing a to the 5th power, a to the 4th power. In this case, n is called the index of the radical, and a is the radicand. When a number has more than one root, the radical sign indicates only the principal or positive root. So that's not the same as solving an equation. Like if we solve an equation, we say x squared equals something, then we get plus or minus. But if it's just the radical is there, then you just have that number. Numbers and types of real roots. If you have an odd index, like the cube root, 5th root, 7th root, 9th root, okay, then there's only one real root you can have. Like here it says the real 3rd root of 8. That actually means the cube root of 8, which we know equals 2, because 2 cubed equals 8. Okay? So if the index is odd, you get one answer. Okay? If the index is even and the radicand is positive, then you get 2 real roots. Like this one says the 4th roots of 16 are plus or minus 2. All right? 4th root, 16 plus or minus 2. Okay. So if the index, the 4, is even and the radicand, 16, is positive, then we have 2 real roots. If we have an even index and a negative radicand, then there are no real roots. All right, so I want to show you something. 4th root of negative 16. Here's why. Take out your calculator. So all of these indexes, you can put them in your calculator on the math key. All right, you know how to do square roots. I can do cube roots right here with number 4. Could do the cube root of 8, and I would get 2. Okay. Now, the 4th root, if you want to do the 4th root here is number 5. Right? And I'm actually going to show you another way to do that before we're done today. But for 4th root, then, what you need to do is you'd have to put in 4 first of all, then go to the math key and choose number 5, all right, and then put your number in there. Okay. So the 4th root of 16 is 2, but it could also be negative 2 because 2 to the 4th power equals 16 and negative 2 to the 4th power equals 16. So it could be either of those two. But look what happens when I try to use a negative. So if I try to do the 4th root The fourth root of negative 16, right, it says there's a non-real answer. That would be a situation where we would get I, if you remember working with the complex numbers from chapter 5. Okay? So you can't do even index, negative radicand. There are no real roots there. You get a non-real answer. If the radicand is 0, then the answer is 0. Okay? The 25th root of 0 is 0. Okay, it doesn't matter what the index is. Okay, because 0 to any power is what? 0. Okay. So if it has an odd index, you can only have one real root. Even index, positive radicand, 2 of them. Even index, negative radicand, none. And a radicand of 0 is just 0. So it wants to find all the real roots. All right, so when this says the 6th root of 64, basically that means this. What numbers can I raise to the 4th power and get 64? Okay. So this basically says this. The 6th root of 64 is equal to what? Or the 4th root of 64, excuse me.
Why is it 6? It's actually 63.
Oh, it does, doesn't it? Why? I know I had 6 right somewhere. All right. Saying what number to the 6th power equals 64? 2. Or what's the 6th root of 64? And it's what?
2.
How do you know?
Because I did it.
All right. She did it. All right. So, but since the index is even and the radicand is positive, that means you're going to get 2 answers, plus or minus 2 then. Not just 2, but plus or minus 2, because I could raise 2 to the 6th power and get 64, or I could do negative 2 to the 6th power and get 64. Cube roots of negative 216. Right. Cube roots is what for an index then? Cube refers to what? 3. Okay, is that an even or odd number? Is 3 an even or an odd number? Odd, okay? So since it's an odd number, odd index, then there's only going to be one answer. So then we're talking about the cube root of negative 216. And you could type that right in your calculator. Right? And when you do that, it'll give you negative 6. Cube root, negative 216. Oops, not that number. Cube root of negative 216, negative 6. Fourth roots of negative 1024. All right, so we're saying, okay, some number raised to the 4th power equals negative 1024. What happens when I raise a number to an even power? What do we get? If I take negative 4 times negative 4 times negative 4 times negative 4, okay, am I going to get a positive or negative number? Okay, a positive number. So can I have any number raised to the 4th power and get a negative 1024? Okay, their answer is no. Okay, some of you might try it, but the thing you got to remember is, oh, that wasn't it. That was it. Oh, it was 8. Oops, clear. so there's nothing. Doesn't work. Right? If I try to do the fourth root of a negative number, right, like we did here, it's a non-real answer. So there's no solution to that one. There are no real roots. You could write either thing. So do letter C. Okay? All right, so we're going to look at, now you remember, like the fourth one in our warm-up was the square root of 75. All right, and we did a lot of simplifying of radicals like that one. Did them back in Algebra B. We actually did it twice. Did it in the Algebra 1 book and the Algebra 2 book. And then we practiced it again when we did the quadratics in Chapter 5. Well, we're going to look at not only using the index of 2, but 3 and 4 or 5 and like that. And we're just going to do some of the basic ones. There are some that are a little bit harder that are involved in there, but I'm going to eliminate those from what we're doing. All right, so if you remember the product property, okay, the nth root of a product is equal to the product of the nth roots. In other words, just like we did square root of 75, Stephen said we can do the square root of 25 times square root of 3. We can do that with other roots. Okay, that's why I had you add fourth here, because we could end up working with fourth roots too, okay? Possibly fifth roots. All right, but I think our fourth is the max that we're going to be doing. So what we want to do is this, is that we want to work with things that have the same power as our index. Works for product and quotient. So here we have the fourth root of 81 x to the 12th. So our key number here is the 4. We want to work with things raised to the fourth power. So since I have numbers and variables, I'm going to pull it apart to start with. Fourth root of 81, fourth root of x to the 12th. Okay. Can I write 81 as some number to the fourth power? What? 3 to the fourth. Okay. So I can rewrite this as the fourth root of 3 to the fourth power. And I could take x to the 12th, and I could write that as x to the fourth times x to the fourth times x to the fourth. In other words, I can break it up into x to the fourth powers, things with an exponent of 4. Which I could write it like this. I could do that too. Okay, then you do it like that for you. Okay. Now, if you remember then, what we can do is that if I have the square root of x squared, what does that equal? X. The cube root of x cubed will be equal to what? X also, because whenever these are the same, then it's equal to this thing here. Okay? So the reason for writing as much as we could to the fourth power is that the fourth root of something to the fourth power is that something. So in this case, we get 3, since these two numbers are the same. And then the fourth root of x to the fourth is x. So I have an x, and an x, which gives me x cubed. Or as Miss 40 was saying, you could also write the x to the 12th power. I could say that that's x cubed to the fourth, so that I have 4 there and 4 there. And that would work also. Good call, 40. So that simplifies the 3x cubed. Okay, let's look at letter B. All right, we're also using 4th power again. Now, lots of times, my first step would be to simplify a fraction if I can. The only thing is, with this problem, is that my denominator already has something raised to the 4th power. And so I don't want to simplify that fraction because I don't want to get rid of the fact that 2 to the 4th power equals 16. I don't want to lose that. Now, here's what we're going to do. Is that we're going to take these and we're going to break them apart. The numerator and the denominator. In the numerator, 4th root, 162, 4th root, x to the 9th, denominator, 4th root of 16. So what we want to do then, just like we did with this 75 up here, we wanted to find, with that 75, we wanted to find a number squared that went into 75. Okay, and we knew that 5 squared, or 25, goes into 75. We wanted to find a perfect square. Well, what we want to do here then is we want to find a perfect number to the 4th power that goes into 162. So let's think about our numbers for the 4th power. Okay. We have 1. Okay, what's 2 to the 4th power? 16. It's right there. Okay. What's 3 to the 4th power? 81. What's 4 to the 4th power? Okay, 256, all right? Well, it can't be 256 because that's bigger than 162, right? All right. Does 81 go into 162? Okay, right. It does. So I can write the 4th root of 162 is the 4th root of 81 times 2. Now, the reason that I broke things up into powers of 4 earlier in the other one, up here, is because now I have x to the 9th power. Does 4 go into 9? No, it doesn't. Okay. So what I'll have here then is I'll start writing the number of, that I can, x to the fourth power. So we have x to the fourth power, that gives me 4. Okay. If I write x to the fourth power again, what's my power now under the radical? Because I'm multiplying with the same base, so what do I do with the exponents? You add them. So what's 4 plus 4? 8. But this was x to the 9th, so I also need another x here. And in my denominator I have 2 because the 4th root of 16 is 2. Might as well make it that now. So the 4th root of 81 is what? What number raised to the fourth power is 81? 3. So we get 3 times the 4th root of 2. All right? Because the 4th root of 81 is 3, so the 3 comes out. I have the 2 left in the under the radical. Over here with the x's. Okay? The 4th root of x to the 4th is x. And then the other 4th root of x to the 4th is still x. So we have x squared, and we still have this 4th root of x here. And we have our denominator of 2. So we can combine them. Because the 3 and the x squared are outside the radical, I can put them together. Because the 2 and the x are inside the radical, then I can put them together. 4th root of 2x. And then I have 2 in the denominator. And that's my answer. So we're trying to find things that raise to the power of the index that will give me those numbers. Whether it's squared, like we've done before, earlier in the Algebra 2 book, or if they're cubed or whatever today. So, okay, raising to a power. Rational exponents just mean we have a rational exponent just means we have a fractional exponent. All right. 16 to the 1/4 power. When you have a rational exponent, the denominator is the index. The numerator is the power under the radical. It can be written as 2 ways. So the a raised to the power of 1 over n is equal to the nth root of a. Or, like this example they have here, 8 to the 2/3, that can actually be written 2 ways. As the cube root of 8 squared, or I could write it as the cube root of 8 squared. It can be written either way. You just have to look and see which way is you're going to be able to simplify it the easiest. One way works much easier than the other, but both of them will produce the right answer. Okay? So if we have right here a raised to the power of m over n, the denominator is always the index. The numerator can either be on the outside, okay, if you're using parentheses like here, or can be on the inside here. And you actually can look at it both ways and see which way is actually going to allow you to simplify the easiest. So we're going to write in radical form. It says write the expression -32 to the 3/5 in radical form and simplify it. So I can do it 2 ways. I can write it as the fifth root of negative 32 cubed, or the fifth root of negative 32 to the third power. Either of those two will work. Now, one of them is easier than the other one. In this case, the one on the left here is easier because negative 2 to the fifth power is negative 32. And if I cube negative 2, what do I get? Okay, negative 8. Because 2 to the third power is 8. Okay, so I get negative 8 here. If I did it the other way, well, I don't know what negative 32 to the third power is, so I have to pull my calculator out for that. Oops. That's what I meant. All right, and that's this big number, negative 32,768. Anybody know what the fifth root of that is? Sure you do. It's negative 8. Okay? But you didn't know that otherwise. Right? And so when you're writing these, to evaluate them or simplify them, you need to look at, okay, which one is easier to work with? All right, to do that. Sometimes it'll be finding the root first. Sometimes it'll be finding the power first. Okay? But the denominator for your fraction is always the index. The numerator is your exponent for the radicand. So do B, A, and B. Okay. Going the other way. All right, so we just took the fractional exponent, wrote it as a radical. Take the radical and write it as a fractional exponent. So the index is the denominator for the exponent. Your exponent under the radical is the numerator. So this is 13 to the 4/8 power, or 13 to the 1/2. Okay? Well, of course you do. Which this is the same thing as, you didn't have to write it that way, but it's the same thing as the square root of 13. Okay? So really, the 8th root of 13 to the 4th, same as the square root of 13. But the number we're looking for here is 13 to 1/2. It says write it using rational exponents. Okay? Letter B. 13 raised to the power of 5 over 15. 5 over 15. Look at that. I just wrote it wrong. How about 15 over 5? Okay. The index is the denominator. 15 divided by 5 is 3. So what's 13 to the third power? 2,197. Okay. Good idea to give both. So rational exponents, the denominator is the index, the numerator is the power under the radical. Or if you put in parentheses around the outside of the whole thing. Okay? Okay? Rational exponents also have the same properties as integer exponents. In other words, if we're multiplying with the same base, we add them. If we're raising to a power, we multiply them. If we're dividing with the same base, we subtract. All those rules apply with rational exponents just like they did with integers. Letter A, 7 to the 7/9 times 7 to the 11/9. What am I supposed to do if I'm multiplying with the same base? What do we do with the exponents? Okay, we add the exponents. So I have 7 to the power of what's 7 ninths plus 11 ninths? Okay. 18 over 9, right? I have a common denominator so I can add them. Mr. Greca. All right. Okay, what's 18 over 9? 2. All right, and 7 squared is 49.
So the answer is 49?
The answer is 49.
Okay.
Letter B, we're dividing with the same base. So if we have the same base and we're dividing, we're going to subtract the exponents. In this case, since the larger number is in the denominator, we're going to leave it there. So we'll have a 1 in the numerator. What's 5/4 minus 3/4? Okay. 2/4 or 1/2. So this is 16 to the 1/2 power, or what's 16 to the 1/2 power?
8, 4.
Okay. How'd you get 4?
Just 16 is a perfect square.
Okay. All right. 16 is a perfect square. Because I could also say this is 1 over the square root of 16, and the square root of 16 is 4. Because remember, the 1/2 power, square root, right? 1/3 power would be cube root. Right? And if we have the exponent on the outside, so if we had If we had 3 to the 1/3 raised to the 1/5, in that case we multiply. So that would be 3 to the 1/15 power. Multiply them.